Okay, let's unpack this. Today, we are plumbing the depths of ocean biodiversity loss. We're taking a deep dive into the true scale of marine species extinction. You hear a lot about land animals, but what's really happening beneath the surface? Our guide for this is a really definitive 2023 review paper. It's titled Marine Extinctions and Their Drivers, and the lead authors are Athanasios Nikolaou and Stelios Katsanevakis. And they didn't just, count the losses. They analyzed decades of data to figure out exactly what the ocean has lost, and maybe more importantly, how and why those losses seem to be speeding up.
That's absolutely right. And for you, the listener, our mission here is really to synthesize the complete picture this paper gives us. The authors, they undertook this massive scientific synthesis. They followed these incredibly rigorous guidelines, Prisma Eco Evo, they're called, for systematic reviews.
Okay, so really robust methodology.
Totally. And they cross-referenced everything with the IUCN Red List data.
Yep.
The whole point was to move beyond just looking at isolated reports.
And get that bigger picture, right?
Exactly. To identify clear global patterns and drivers. Honestly, it's probably the most complete, well-informed overview we have right now of the marine biodiversity crisis.
And this investigation, well, it couldn't be more critical, could it? We're navigating what a lot of people call the Anthropocene, the age where humanity is basically the dominant force changing the planet. On land, the global species extinction rates are just horrifyingly high. We're talking 100 to 1,000 times higher than the natural background rates. Now, traditionally, the ocean, it seems safer somehow. The IUCN lists only about 21 conclusive global extinctions. But that number, it's really deceptive, isn't it?
It really is. You have to distinguish the threat here. While the number of species that have vanished completely globally might seem low, and this paper confirmed 18 highly conclusive global ones,
Right.
The real story, the alarming one, is this vast and accelerating record of local extinctions, ecological extinctions, commercial extinctions.
So disappearances within specific regions or functions, even if the species exists elsewhere.
Precisely. These are the losses happening sort of below the global radar. But they are absolutely devastating to how ecosystems function and to the services the ocean provides us. Think food security, coastal protection, things like that.
And the paper documents this really dramatic shift in what's causing the devastation.
Yeah.
Historically, marine life faced pressure from the obvious things. Overexploitation, think industrial fishing and habitat destruction from coastal development, pollution.
The usual suspect.
Right. But the analysis notes that while some management efforts have actually helped mitigate some of those effects, which is good news, two massive forces are now really dominating the conversation: climate change and pollution. And their impacts seem to be peaking at the same time.
So to conduct this massive review, the researchers, they searched the global scientific literature. They were looking for reports of any local, regional, or global extinctions or even population collapses. After a really rigorous screening process, they ended up synthesizing data from 194 included articles. It's a huge data set.
And they were careful about the scope, too, like what they didn't include.
Yeah, that's important.
They excluded losses from before the Holocene. That's roughly the last 11,700 years since the last ice age. So they're focusing squarely on recent human impact. And crucially, they also didn't count temporary local disappearances, populations that might vanish from an area but then successfully recolonize later. They wanted confirmed lasting losses.
Which brings up a really important question for you, the listener. How do scientists actually know an extinction report is reliable?
Wow.
How do they verify it? And what's fascinating here, what makes this paper, I think, so important, is that the authors developed a critical appraisal system.
Right.
They basically recognize, look, if you're pulling data from decades of global literature written by countless different teams, well, not all reports are going to be equally reliable.
Exactly. And this feels almost revolutionary in conservation science, doesn't it? Instead of just taking every report at face value, they created this validity scoring system. It's on a scale of 0 to 10. And they categorized reports as low, medium, or high validity. And they applied this based on, 5 key variables?
Yeah, 5 variables. Things like, how was the species absence actually detected? Was it a direct survey? Or just comparing old lists, what was the temporal coverage like? How often and how recently did they check if the species was still there? And critically, what was the quality of the evidence used to blame a specific driver, like climate change or pollution?
That kind of systematic rigor seems absolutely crucial for cutting through the noise, maybe questioning some of the low-confidence data that's out there.
Absolutely essential.
So, okay, That validity score provides really important context as we get into the headline findings. Because the numbers are big, forget the total count for a second. The real sort of seismic shift they found is this. The review recorded 717 local extinctions overall. But they found a staggering six-fold increase in the reporting of local extinctions just since the last big synthesis effort, which was only 2 decades ago.
Yeah, that acceleration is horrifying, really.
A six-fold increase in reports.
Wow. And those losses, they aren't evenly spread across the globe. If we connect this to the bigger picture, the review identified clear geographical hotspots, 2 main ones, really. The temperate northern Atlantic accounted for a huge chunk, 41% of the recorded extinctions.
41%.
Yeah. And the central Indo-Pacific was next, at 30%.
So heavily concentrated. And drilling down on the scale of those losses.
The vast majority, 56%, were found on a really localized scale. Think small bays, harbors, the shorelines, right off coastal cities.
Okay, so close to intense human activity.
Exactly. Another 35% were sub-ecoregional, a bit larger scale.
Yeah.
But it really highlights that the danger zones are often those closest to us.
And what kinds of species are we losing, taxonomically?
Well, the losses cut across various groups, but mollusks, that's your clams, oysters, snails, that kind of thing, they were the most affected group. 31% of local extinctions.
Okay.
Following them were cnidarians, which includes corals and jellyfish. They were at 22%. Then fish at 17%, and macroalgae, like seaweeds, at 15%.
Any specific examples that really drive it home?
Yeah. One that stands out is the iconic giant clam, Katsanevakis, a really well-known species. The review found 9 separate local extinctions reported just for that one species across its range.
9 local losses for the giant clam alone.
Okay, now let's talk drivers, because this is where the story about why the ocean seems to be dying really changes based on this paper. When they looked at all 717 local cases combined, what came out on top?
Pollution was the most frequently reported driver. That accounted for 302 cases.
Wow.
Followed very closely by climate change at 273 cases. Then came habitat destruction and overexploitation.
But the really interesting part is the change over time, isn't it?
Yes, the temporal analysis is absolutely key to understanding the crisis we're in now. The review clearly showed that, well, up until about the mid-1990s, the primary drivers reported were indeed overexploitation, pollution, habitat destruction.
The things we traditionally think of. Right. But since the late 1990s, there's been this substantial and, frankly, relentless increase in reports attributing extinctions specifically to climate change and climate variability.
It's like the narrative shifted, didn't it? From, nets and bulldozers near the coast to carbon emissions and warming waters affecting everything.
That's a good way to put it.
And you can connect that primary driver to the species mobility too, right? That was another key finding.
Yes, absolutely. They found a really significant pattern there. High mobility taxa, think fishes,
right,
marine mammals, seabirds, things that can move large distances. They were driven extinct predominantly by overexploitation.
Okay.
For instance, among chondriches, that's the group including sharks and rays, a staggering 87% of all the recorded local losses were attributed to overexploitation.
87%. So we were fishing them out, basically.
Pretty much. Conversely, the low mobility taxa, like those mollusks and cnidarians we mentioned, corals, clams.
Things that are stuck in one place.
Exactly. They were predominantly driven extinct by factors they couldn't simply swim away from. Pollution, climate change, climate variability, and habitat destruction. If the water gets too warm or too polluted in your local bay and you're a clam, well, you're stuck there.
Well, that's a massive finding. I just want to pause on that for a second. If climate change is now the dominant reported driver for these local extinctions, what about the 18 confirmed global extinctions? The paper notes the last one was the Chinese paddlefish back in 2003. And those 18 global cases were mainly attributed to overexploitation. You said 13 cases, or invasive species, 7 cases.
Yeah.
The really striking thing is this. According to this review, no global marine extinction recorded was attributed solely to climate change. How does that square?
That is the critical tension this paper really brings to light.
Yeah.
And it's not necessarily a hopeful sign, unfortunately. It might point to a time lag. The lag between widespread local collapse and the final global disappearance of a species. It could suggest that while warming oceans and acidification are creating this local extinction debt, meaning these losses are kind of baked in, inevitable, those climate-driven species just haven't quite tipped over the global edge yet. Or it could also be pointing to a data gap, especially for endemic species that only live in one specific area. If they're lost locally, that is global extinction, but maybe it hasn't been documented or confirmed robustly enough yet.
Which brings us right back to that all-important validity score, doesn't it? The critical issue of data quality.
Exactly.
Because this data gap seems huge. You mentioned the majority of those 717 reported local extinctions actually fell into the low or medium validity categories.
That's right. Take the Central Indo-Pacific, one of the hotspots. A sobering 65% of its reported extinction cases were deemed low validity by the author's system.
65%. That's most of them.
It is. And this lack of confidence, it stems largely from the methodology used in the original studies. A staggering 69% of all the recorded extinctions they reviewed relied on indirect detection methods. Often, it was just comparing historical biodiversity lists from, say, the 1950s with a modern list.
So not actual field surveys looking for the specific species.
Often not, or surveys with very poor temporal coverage. If you only check once or twice over several decades, especially in remote or hard-to-access areas, you can't be truly certain something is gone forever. The coverage just isn't there.
And the evidence linking the extinction to a specific cause was often weak too, you said.
Also weak, yes. The most common way the driver was identified in the original reports was simply expert judgment that accounted for 62% of the cases.
So someone knowledgeable saying, yeah, it was probably pollution.
Basically. Or using non-experimental correlations, which was another 25%. The temperature went up and the species disappeared, so it must be climate change.
Without proving causation.
Right. Strong inference evidence, like manipulative experiments where you actually test the cause and effect link, that was incredibly rare. Only 1% of the cases used that kind of robust evidence.
Okay, so what does this all mean for conservation management if the data is often shaky?
Well, the biggest implication is this gaping hole in our knowledge. And it's really evident when you compare their findings to the official IUCN Red List. This is shocking. 53%, over half of the locally extinct species recorded in this review, had not been assessed by the IUCN Red List at all.
Wait, say that again? Over half the species they found reports of local extinction for weren't even on the official conservation radar.
Not assessed at all. They weren't listed as threatened, near threatened, data deficient, nothing. Just not assessed.
How are we supposed to manage a crisis if we don't even know which species are disappearing locally?
That is precisely the profound risk the authors highlight. It's this phenomenon of silent extinctions.
Silent extinction.
Losses we don't even know we're suffering because we haven't been looking closely enough or with the right methods.
It sounds like trying to put out a massive fire when you can only actually see half the flames.
That's a good analogy. And if we look at the broader ecological consequences of these local losses, even the ones we do know about, they can be catastrophic. Especially when you lose species high up the food chain, the apex predators. You get these severe cascading effects through the ecosystem. There are documented cases, like the collapse of valuable scallop fisheries in North Carolina Bay, which happened after the local disappearance of the apex sharks that used to control intermediate predators.
Right, everything's connected. And we need to focus on climate change hotspots too, you mentioned.
Definitely. The Mediterranean Sea, for instance, is identified in the paper and other research as a major climate change hotspot. This makes its endemic species, remember, those found nowhere else, incredibly vulnerable. Why? Because physical barriers like the Strait of Gibraltar or land masses prevent them from migrating poleward to cooler waters as temperatures rise.
So they're effectively trapped in a warming basin.
Exactly. They have nowhere to go.
This all sounds quite dire. What's the path forward? What does this demand in terms of research and action?
Well, it demands a fundamental shift. We urgently need improved conservation and restoration efforts. But more than that, we need to move beyond just trying to sustain the status quo, trying to hold on to what's left. The focus needs to shift toward actively rebuilding and recovering marine ecosystems where possible. We can't just manage decline, we have to actively promote recovery.
And that requires tackling those data limitations we talked about, right? Getting better information.
Absolutely. That's foundational. Future research must prioritize continuous ecological monitoring, and we need innovative, cost-effective tools that give us high-confidence data, ideally closer to real time.
What kind of tools are we talking about?
Things like advanced remote sensing from satellites, using sophisticated AI algorithms to help with species recognition from images or video, and crucially, environmental DNA, or eDNA.
Ah, yes, eDNA, where you sample the water itself.
Exactly. You filter water samples and can detect the DNA traces left behind by species that have been present recently. It's a powerful, non-invasive way to monitor biodiversity, especially for rare or elusive species.
So, summing up the review's contribution.
In final synthesis, this Nikolaou and Katsanevakis review provides absolutely crucial spatiotemporal information on marine extinctions. It clearly shows this rapid, six-fold increase in reported local losses over just the last 2 decades. And it documents that clear, recent shift in the reported drivers, moving towards climate change and pollution as dominant factors.
But the final, maybe provocative thought we really take away from this deep dive is unsettling. Even with that alarming six-fold acceleration in reported extinctions, that low validity score attached to so much of the historical data suggests something stark.
Hmm.
It suggests that many, many more extinctions might be going entirely unnoticed, flying completely under the radar. The true scale of the damage to our oceans could be far, far greater than we currently know, precisely because of these pervasive, silent extinctions. Thank you for joining us for this deep dive.